Oh yeah, well thanks again everyone for coming, and of course, to everyone who's watching and joining us remotely and everything like that. This is our first event, and for us as a relatively small company, a growing company, it's exciting to bring together all of the community and not just sort of meet here, in person in Portland, but also have the opportunity to build this content that we will share with all of the users around the world. So the thing that I wanted to talk about was how different organizations can choose the correct platform to develop on today. I'll give you a little bit of background on myself. I am the founder and CEO of Inedo, and as you know, Inedo, we make a suite of DevOps tools, but we didn't always used to do that. Back in the day, we were a software process consultants. We also wrote custom applications, developed code, and to be honest, I still kind of think of myself as a software process consultant these days. I've had the experience and pleasure of helping a lot of different organizations around the world do what we'd call today DevOps transformations. But I've watched successes and failures of these organizations and have learned a lot of it, especially from some of the failures. So I want to tell you guys a little bit about my first job in an enterprise. This company, it's called Ohio Savings Bank, and this is a very interesting company. It's 115 years of legacy at the time that I joined it. And I was brought on this is a long time ago, right, as a .NET developer. And to be honest, it wasn't something that I was that interested in. I didn't want to work inside of the enterprise. I didn't want to do all the enterprise process, work on all those enterprise things. I was a developer. I wanted to code. I wanted to build systems. But when I was applying for the jobs, they sold me on this idea of their transformation initiative. So the transformation initiative sounded awesome. The first thing that they were going to do was embrace the latest and greatest of technologies. What this would do is this would enable them to unify all of the different teams that were all doing their own different things. This would allow them to then start rapidly iterating and releasing software applications and changes to all of the things that they were working on. And one of the key things that this would enable is them to finally use software as a strategic asset. Now, as a .NET developer, somebody who's very excited about all this sounded fantastic. My image of banks are what? COBOL, mainframes, all these old, crusty, legacy technologies that nobody wants to work on. But the bank, they knew what was going on, and I was very, very excited to be a part of it. So one of the first things that I like to do when I build software is try to understand the underlying business problem. So I dove in and I tried to do that. There's a problem. Nothing made sense. There was, try as I might, I just could not figure out what was going on at the bank. They had so many business problems that I just couldn't understand them. Now don't get me wrong, I understand the basics of banking. It's actually very simple. The customer gives the bank money, the bank gives them interest in return, and the bank takes that money and loans it to other customers at a slightly higher interest rate. It's a very simple concept and problem that's as old as money itself. We all get that. I even get some of the complex stuff. Take mortgages, for example. It's like that loan concept, but applied to a house and over 30 years. And if you don't pay, then they have a lien on your house so that they can foreclose on it. And then there's all sorts of paperwork, regulation, paperwork, rules, paperwork, all these sorts of things to make sure it works out for the bank, the borrowers, and everyone else. I went through a mortgage before starting the bank and understood how it worked. And despite all that, nothing made sense. It turns out mortgages were even more complicated than I could ever have imagined. I couldn't wrap my mind around them. I remember looking in our software, and they had all of the fields. I mean, if you've ever done a mortgage and have seen the paperwork that you have to do, on the bank side, it's 10 times that. But anyway, there's a field in our software, and I remember it. It was called, it was a checkbox, and it just said Nina. And I went to developers, and I said, well, what does that checkbox do on the underwriting application? And the developer said, oh, well, if you check that box, that specifies that it's a Nina loan. I said, well, that's not actually very helpful. So I went around and I tried to really find out what a Nina loan actually was. I learned eventually from an underwriter that a Nina loan stood for, it's an acronym, no income, no assets. So it signified to underwriters that the borrower did not declare any income or assets. Actually, that didn't help me understand things any further because that also didn't make sense. To make matters worse, it turns out that our department didn't actually create mortgages. They just funded them, kind of underwrote them, and then they bought them from people that did. It was called the Wholesale Mortgages Department. And this is a problem I still couldn't quite understand because I wondered, well, why would you buy mortgages from people who can check off no income, no assets? Finally learned that actually what they do is they take a lot of these loans and then they put them in what they call a bundle. And then, in addition to the loans, they buy something called an insurance. I forget the name of it. It was like an insurance or something, so that if some of the loans didn't go, then everybody would still get money. Then they would sell those to investors. By the way, this process took me months to unwrap and figure out. And none of it made any sense. No single person inside of the organization could explain any of these concepts to me. And at the end of the day, I just sort of gave up on wrapping my mind around all of the problems that the wholesale mortgage department, which is just one small group in the organization, solved. This is where I learned my first lesson in this concept of incomprehensible complexity. The bank's organization, the thousands of people that worked there, enabled this incredibly complex business problem to be solved, and it was the software that tied together all of the people to do it. No single person could understand it all, but everybody working together using software and the technology was able to do it. And what was interesting to me is that everybody as an individual contributor could still contribute to solving the underlying problem at hand. That being said, I kind of, shortly after learning about what the business did, I really lost interest in what they were doing, but I guess it didn't work out so well to sell loans that people couldn't pay back, and it caused this whole problem with no income, no asset loans. And eventually the bank went under, foreclosed, all those things themselves. But before all that happened, I got my first taste of what software was like in an enterprise and how you build software that solves incomprehensibly complex problems. And I remember, I'll never forget my first assignment that my boss gave me at the time. He handed it to me and said, all right, Alex, this should keep you busy for a couple days or something. And I was excited. I'm like, okay, what does this mean? So I contacted the user, Wendy. And Wendy was very kind enough to very eagerly explain the problem. When they were doing some sort of underwriting something or other, who knows, I couldn't understand that. Basically, the wrong document was sometimes getting attached to an underwriting request. That wasn't too big of a problem because they could just delete that document and then add the correct one. But the problem was that required manager's approval, which meant chasing down a manager, and at the end of the day, it was slowing loans down for days, adding customer frustration. The mortgage processes were getting headaches, and the thing that floored me was this ticket was open for more than a year. It was as people on the development side just didn't care. I wanted to try to fix that. I was excited, and I was dedicated to have my first assignment solve Wendy's problems and solve that team's problems. The user translated the business rule to me very, very simply. It was very simple. If a underwriting thing, whatever that was, had a approval flag of DUP, just change the document that you're attaching from VFY or CHK to VFY, something like this. So it didn't take me too long to find the code. It looked something like this. This was the only part in the code that these codes existed. This was the only place. It turned out to be something on the front end, maybe a JavaScript bug or something like that. Once I found the code, it was a very, very simple fix. It was just this 3-character code change. These 3 characters were causing so much business pain, so many business problems, and I solved it within seconds. I was very excited. I checked in my code, I went to my manager and said, I have just made everyone on the business's day, I solved the problem. And he's like, I knew you could do it, Alex. Okay, now here's a real assignment for you to do. Actually, just kidding. His face went white. He's like, wait, what? You checked in code? When I handed you the ticket, Alex, I said, tell me what it would take. I didn't say do it. What I was looking for you was an estimate of the level of effort that it would take. Because then I could take that estimate and bring it to our prioritization meeting to see if I can allocate the hours done to take that. At that point, I realized I didn't really understand how enterprise software development worked either. As it turned out, all of these things were very well documented in the onboarding book, which I never read, but I quickly learned as I was getting scolded about my brash check-in, how it worked. When you build software in an enterprise, specifically Ohio Savings Bank of those days, it all started with estimation. How long will this ticket take to solve? From there, you can do an internal prioritization just with the development stakeholders to then go to a prioritization review meeting. After that, it's very simple. You can then take your prioritization and spend some time doing an approach write-up, but that approach ought to get reviewed and approved, because what if it's the wrong approach to solving the problem? From there, you then write your specific implementation up for how you'll do it. Then, once your implementation is finally reviewed and approved, it can go to prioritization evaluation. This then allows you to finally begin receiving an assignment to change the code. Once you change the code, that's when the magic happens. Code review. It's a simple form, just a few pages. You fill that out, you talk about all the risks, all the problems that might happen with that. And finally, after code review, only 53 more steps to go to get that code to production. There was testing request forms, there were deployment verification forms, then the meetings. Oh, so many meetings. A single line of code. Actually, 3 characters would take 40 hours for me to complete. All the while, the business users are in pain. The end customers are in pain, all for this nonsensical process. I understand risk reduction, but this is ridiculous. I knew at the time that there had to be a better way. I had worked in smaller companies where we could take ideas from customer ideas to execution in weeks, in months, as soon as the customer wanted. In our case, we were prevented from serving the customers, who are the banking users. But it turns out that actually the bank was already on this problem. They realized how horrible this process was, and that's what the transformation project was all about. What they had done is they had found a wonderful consulting company. This company was the formation of 2 of the greatest companies in the world, Microsoft, innovators in technology, and Arthur Andersen, innovators in business. This joint venture called Avanade would come in and transform the business's processes and technology so that they could finally deliver business value to the stakeholders sooner. After Avanade came in, here's what they realized. First and foremost, the legacy complex code that was powering this incomprehensibly complex system was very, very problematic. It made testing so painful. Everything was manual, done by disparate teams. Nobody knew how to test anything. Deployment was a disaster. Every time there was a deployment, it was an error, a problem. Nothing ever worked. And it was very unreliable, too. And ultimately, their conclusion was this. They were using a completely backwards platform, something called Windows DNA. So what was Windows DNA? It is a technology that not many remember, but here's what Windows DNA did. I found this slide. It's maybe a 20-year-old slide at this point. Windows DNA wanted to provide a common object model on all tiers using COM Plus and distributed COM components in the Windows operating system. It was language neutral and allowed you to write in any language you like, as long as it's VB6 or C++. You could do auto-scaling of everything, not just the the scalability, the reliability. Everything was automatic. The Windows DNA platform solved all of this. And it was available today. Organizations were using it all the time. Well, it turned out this platform was a disaster. Didn't actually work, and this was the cause of all of the bank's problems. So it turned out for Avanade to come in and fix it, they were the ones that partnered with the bank to come up with this transformation vision. This is what it was all about. Embrace technology, unify the teams, rapidly iterate on changes, and leverage a technology as a strategic asset. They would bring in proven technology, things that have been used by other enterprises across the world. Remember, the combination of the business brilliance and the technology brilliance knew what they were doing. This would enable, finally, for once and for all, that fast delivery of changes to stakeholders. This is the power, after all, of modern technology. So this is what they brought in. They brought in this wonderful framework called .NET 1.1. .NET 1.1 was amazing because instead of using all these disparate tools to develop, you could do everything inside of Visual Studio. It was guaranteed safe. There were no buffer overflows or any of the system crashes or any security problems at all whatsoever because it was managed code. It was just provably impossible. Instead of using proprietary COM interfaces, it used things like SOAP and all sorts of different technologies to make sure all the disparate teams could work together on the languages of their choice. So after Avanade, if I had to put it simply, maybe the nice way of saying it was a complete and total disaster. There were so many things that went wrong after launch, but the thing was, none of them happened right away. They could have rolled back if that was the case. No, they happened weeks and months after the transformation, the technological transformation. Their software that this process drove was intended to lay off a floor of mortgage processors. Instead, they had to double the number of people processing mortgages to deal with the terrible software, all in the height of the subprime mortgage day. Very, very difficult to hire all those people. Maybe my favorite anecdote in all of this was that the web application that they had built to displace the slow, client-driven, whatever technology Windows DNA enabled was so bad, so unperformant, that half of the customers, when they loaded in their web browsers, their computer couldn't handle the web page they had built. Instead of fixing the performance problem of the application, this new web application that was supposed to be client-specific, they bought all of their customers' new computers. It was several $1 million, and that was cheaper than fixing the software. Ultimately, the bank chose poorly. Did they pick the wrong platform with .NET 1.1? I mean, a lot of us have worked on old, ancient .NET 1.1. I mean, .NET 2.0 was great. I can remember all the benefits that it had. But I'm sure any of us can articulate all of the problems that .NET 1.1 had and why it was a terrible, terrible platform to make such a big, grand change on. But the new system that they built was even worse than the old one because it was very hard to change, test, and deploy. Fortunately, 15 years later, this is no longer a problem. As an industry, we have learned so much about this. No one is talking anymore about how their legacy systems, their legacy code bases are holding them back. Nobody's wondering about, is a new platform going to come in and save the day? Everybody knows that that platform choice has already been made, and that choice is Kubernetes. It is the perfect technology. You see, it enables the common container model across all tiers. You can build containers in any language that you would like, Node.js, .NET, C++, anything. And what's amazing about Kubernetes is that it does everything. It takes automatic scaling, automatic growth, automatic everything for distributed computing. And by the way, it's a proven technology. Everyone's using it today. Now, this isn't to say that, is Kubernetes a fad? No, it's not a fad. It's not any more of a fad than .NET 1.1 was a fad or Windows DNA was a fad. It's a development platform that purports to offer the same benefits that all the other platforms offer, which is a way for you to build applications and components. The underlying value proposition, it's the same as Windows DNA was, but so are almost all of the new development platforms that have come out in the past 20 years. It also has the same problems that all of the development platforms have. Ultimately, all of these platforms are solving the same problems, but they also have the same types of problems, especially when you go all in and believe that the platform is what's going to enable all of this change. One of the hardest things to do, though, with platforms is recognizing, are you actually using a development platform or not? Back in the day, when my first image of a platform, I used to think it was the operating system. This is why I was so excited about .NET, because it abstracted out all of the very specific things. When you were building for C++, you had to target very specific versions of Windows. But .NET, it wasn't a platform. It was a new way of building software that was platform independent. Turned out .NET was an execution environment and in fact was very much a platform. The language that you write in is a platform. And all of the dependencies that you use, the .NET framework, all of these are platforms that you use to build your software. At the end of the day, there is no such thing as platform independence. Whatever tools that you are using to build, host, or depend on your software is what your software platform is. Software platforms are fine, but it's important to understand what the drawbacks are. First, realize that it's a platform, and then understand what the drawbacks are. So I'm going to talk about a couple platforms that I think, or 3 platforms that some people don't even realize are platforms, and the drawbacks that we will see 10 years down the line when somebody was asking, oh, why is your organization is so disheveled and such a disaster? What was that old technology you were using? First one I want to talk about is cloud native. Now, this is a really interesting concept because what cloud native lets you do is leverage not only the infrastructure of all these amazing cloud providers, Amazon, Azure, Google, right? They've built wonderful cloud infrastructures, data centers all over the world. But all of the technology that they built inside of it, all those services, the storage services, the routing services, the load balancing, basically what you get is you get all of the tools that they built, all the infrastructure that they built, all for your own applications. It is like getting all the scalability that Amazon, Netflix, Google has for only the small subscription price that you end up paying. But what are we going to say 10 years from now when someone says, oh, so what was that whole cloud native thing all about? First thing that we'll say is, it was a little bit like SAP or Salesforce, but for all of your applications, infrastructure, and components. But unlike SAP or Salesforce, you actually had to use all of your own development resources because it didn't have any business value built in. You had to code all of those old modules, those applications, and those components. It also had pretty unpredictable costs. We had no idea what it would cost, but the bills just kept coming in. We tried to reduce costs, and it got really out of hand. Oh, and the platform just constantly changed. Amazon constantly added new features. Azure did this, and so on and so forth. But the big thing that everyone will say is that it was difficult to change, test, and deploy. These constantly changing tools, platforms, and whatnot made it very, very hard to work with. Another platform is this concept of serverless computing. I've had a lot of customers ask and tell us, we're looking to go into serverless computing as our next platform. We think that this is going to finally solve our problems. Now, when I first heard this idea of serverless computing, I kind of got a little confused because I thought, well, code runs on servers. How do you get it to not run on a server? But then they explained it. They said that what's great about serverless computing is that it doesn't necessarily rely on a cloud host. It's actually cloud independent. You could have your own private cloud inside and then do serverless computing. And the idea is this, is that you don't even have to worry about where your applications are running, where they're going. You write code and the cloud service, the platform as a service, takes care of everything for you. All of those infrastructure concerns that you used to have that were driving all of the operations people, giving them headaches, all of those are now abstracted. And serverless computing gives you automatic scaling, capacity planning, maintenance, and you just pay for what you need. Of course, down the line, here's what we're going to be asking when people ask us, what was serverless computing? Basically, serverless computing is like shared hosting, but for message queues. What that means is that you're building small applications that process messaging, but ultimately, because it's based on this concept of message queues, you're going to get a sort of unpredictable performance. Now, even the best cloud providers in the world are not going to be able to solve the problem that nobody will know the amount of load and instantly be able to adapt to it. That is the fundamental problem of message queues and the fundamental problem with serverless computing. The architecture required to build your applications on serverless computing is very complicated. Just like it was with message queues, you need to build new layers, new complexities, and new processes for doing this. The dependencies get out of hand very quickly. When you start having lots and lots of different services that are bundled in serverless computing depending on all of one another, that's now a whole dependency problem. And all of this adds up to one thing. They're very difficult to change, test, and deploy. That will be the fundamental problem that we have with this technology down the line. And sort of the last platform that I wanted to talk a little bit about was containers. This is something that, I'd mentioned Kubernetes earlier, and I wanted to circle back on that because basically the underlying technology is containers, and containers, Kubernetes, they seem so very intertwined today. And a lot of people don't think of containers or Kubernetes as a platform. They see it as platform independence. The idea is that it's write once, run anywhere. But that's not true. You actually have to architect, design, and build your code for containers. When we look back at what containers were, one simple analogy that I look at and think, especially if you have experience on the Microsoft side, is that it's like Com+, but with all of the dependencies built in. Com+ solved a lot of great problems in allowing you to make small applications, small services, small components all work together and gave the distribution platform to do it, but they had the dependency problem with it. One of the other problems that we're going to find with containers, and that organizations are already finding today, is that they're documentation driven. This means that you need to rely on what the developer wrote in the README file, what they wrote in an internal wiki to describe what the container actually does. I don't mean the Docker file, I don't mean the code, I mean how you interface with the container, what the interfaces are, and how the architecture all works. Without that documentation, all you will have is, just like an old Com+ registry, a ton of running services that no one knows how to untangle. Containers are complicated. They will require specialized hosting. Kubernetes is one of those hosting platforms, and the orchestration to get all of the pieces to tie together. None of this is built in. A lot of this is a growing technology, and it's also constantly changing, like all new and advanced technologies. We'll also say that containers are slower and more complex than just simply deploying the code. And ultimately though, we'll all feel containers, those were really difficult to change, test, and deploy, because if we deploy one container that could take our whole cluster down. Testing was difficult because we could never get in the business hands on time. And deployment, well, we had the guy who just typed in that command on the command line, but we never figured out how to actually get it through our process. So I just want to be clear that we're not against these technologies. I think that containers, cloud native computing, serverless computing, everything back to Windows DNA, they are all fine technology platforms. They all have their benefits. We can look at Windows DNA and think how ridiculous it was. We can look at .NET 1.1 and think, boy, all those problems that it has, but that will happen with every single platform that you choose. I had like a .NET, I was tempted to get the .NET tattoo because I love .NET so much. But it turns out it's evolved a lot, it's still around. Will it be around in 5 years? Probably, but we don't know if it's going to be the platform that we build on. What I do know is no matter what technology you're using, what platform, all are difficult to change, test, and deploy. It's because all software is difficult to change, test, and deploy. This has been true for my entire career as a software developer. At first, it seems oh so simple. Just run this quick command line, or just inside of Visual Studio, click the publish to a server button, and it goes straight to production, right from the developer's hands. But when you start incorporating these technologies into organizations with incomprehensible complexity, with people constantly moving jobs, constantly going from one place to another, it becomes more and more difficult. This is actually what I founded Inedo on, was that I wanted to make software that would enable easy changing, testing, and deployment of all applications. I think back 15 years ago, if Ohio Savings Bank had used a proper tool like ours to deploy that Windows DNA monstrosity, they could have slowly chipped away at all those legacy problems. They could have built a process that worked on any platform, .NET 1.1, .NET 2.0. They could have introduced Node.js or whatever applications came in the years that their organization grew and adapted. If you have the right mindset to build a software process, you will have the ability to deploy any, regardless of the platform. So my final thoughts on this are that it's really not about your platform choice. You can use anything from Windows DNA to Kubernetes. It's really about your adaptability as an organization. The processes that you design to work with all software, and the flexibility in those processes so that they can work with the disparate teams. There will always be disparate teams that always want to use their own processes. But if you build processes they can all use, then you can all be more adaptable as an organization. The culture that you foster through interconnectivity, letting everyone know what's going on, giving visibility into not just the very technical things that the developers are working on, but letting the developers share the status of all the different applications and components that everyone's working on. And it's the tools that you use to tie these processes together. These are very independent from the platforms that you're using to build your applications. We are committed to continuing to build the tools that help you do this. Whether you're using legacy platforms, these still deliver so much business value today. Whatever you want to use today, we have the ability, and we want to continue growing the ability to develop things that address the latest technology. And we have been doing this for years, and will continue to enable our users, our customers, to use whatever platform they want in the future to build and deploy software. Mike gave a great summary of today's event, but I just wanted to add that, this is our first community event, and I appreciate everybody who encouraged us to do this. Portland is far for a lot of the folks that came here today, and I know we've got so many people who wanted to join that will be watching in their offices, that will be watching remotely. I also wanted to make sure today that I shared, our vision of what Inedo is. We sort of shared this idea that we're not out to sort of build the next great development platform, this monolith, this all-in-all, end-to-end, platform where all of your code, all of your applications will be built, use that. What we want to do is help you build the tools that help you deliver software. But a big thing of this too is learning from you. We want to learn from, there's different sessions that you can learn from other users, but I really want to talk to everyone. I want to learn, what are the problems that you're facing, maybe with our tools, but also what are the problems that you're seeing in your organization that we can work to help you address. And ultimately, I don't know if everyone knew this, but we are one of the few companies in this space, in software in general, that does not have venture capital, that does not have growth capital funding. We are all self-funded as an organization. I mention this because this means that we are not accountable to venture capitalists, to growth investors who want to see Inedo start acquiring other companies, getting high return on multi, 8, 9-figure checks. We're accountable to you, our users, and we want to continue to build software that's going to help you solve problems. We ultimately need to continue building tools that deliver you value so you can continue to help fund us and help us grow. Finally, the theme that we're really building the event around, but also our company around, is this. I want everyone to get back to developing, to stop focusing on constantly worrying about shifting platforms and how to adapt this. This is ultimately what we're tasked with doing as engineers, is delivering business value. And this is ultimately what I want to enable all of you to do through our tools and through our services. Thank you very much.